Hey there, awesome physics students. Let's talk about how to resolve vectors into their components. So what are components anyway? Well, those are the parts of a vector that point along the x and y directions. Let's start with an example. In this example, we have a vector A, which has a magnitude of 10 meters. Remember, the magnitude is always positive, and it has an angle of 30 degrees to the horizontal. So to get the parts of these that lie in the x and y directions, we need to establish the x and y directions. So let's draw a standard xy coordinate system here. That's the x direction and the y direction here. And the idea with components is that you want to find the parts of A that point in the x and y directions. So to do that, I do this little mental model here where I imagine I have a flashlight and I'm shining that flashlight down perpendicular to the x-axis. And when I do that, that means that the vector A is going to cast a shadow along the x-axis, and that length of that shadow is my component AX. That is the part of A that is parallel to the x-axis. And similarly, I can do the same thing with the y-axis. I imagine a flashlight, and I'm shining that flashlight perpendicular to the y-axis, and that's going to cause the vector to cast a shadow along the y-axis here, and the length of that shadow is going to be my vector component AY, which is the part of A that is parallel to the y-axis. And just a note, AX and AY are scalars. They're just components, so they can be positive or negative numbers. Okay. To actually find the values of AX and AY, I just need to use the things I know from trigonometry and right triangles. So you notice that these, when they cast a shadow, they make a right triangle here. And so I can compute the value of AX by taking the hypotenuse here, that's 10 meters. And this side is adjacent to the angle 30 degrees. And so I want to use the trig function that involves that. That would be cosine, because cosine involves the adjacent side. And when I compute this number, 10 times cosine of 30, that gives me 8.67 meters. I computed that ahead of time. But you would just use your calculator for that. Similarly, for the y component, I want this length here, which is the same as this length here. And this length here is opposite to 30 degrees, so I want to use sine. So this is going to be 10 meters times sine of 30 degrees. And when I compute that number, sine of 30 degrees is half, so that's going to give me 5 meters. Okay? Let's do another quick example so you can see how this works. So imagine we have another vector B that lies along this direction, and imagine it is 8 meters long, so the magnitude is 8, and remember the magnitude is always positive, and it has an angle of 40 degrees to the vertical. Okay, so this is a little different scenario. And again, I shine my flashlight here and I find my right triangle here, and well, I need to draw my x and y axis. We often draw the x and y axis like this with the vector at the origin. You don't have to put the vector at the origin. Remember, you can move these vectors around however you like, but for convenience we're putting it at the origin so we can find this. So you'll notice that in this scenario, B points in the negative x and negative y direction. So let me just extend my negative x-axis out this direction, and my negative y-axis is already sort of there. All right. So to find the component by that points parallel to that is the part of B that's parallel to the y-axis, I want this side here, which is adjacent to the 40 degrees, so that would be 8 meters times cosine of 40 degrees. And if I compute that, that's going to be, I did this ahead of time, so this is 6.31 meters, and don't think I'm doing this in my head. I computed that ahead of time. I'd use a calculator for that. Similarly, I want to drop a perpendicular here. I'm going to shine a flashlight like that perpendicular to the x-axis, and I want this length here, which is BX. That is the same as this side right here. That is opposite to the 40 degrees, so that's going to be 8 meters sine of 40 degrees, which I computed that ahead of time, and that's going to be 5.14 meters. Okay, so the components here are given by that. Now there's one more thing that I need to do. I didn't even address it. You notice that this vector A pointed in the positive x and positive y direction, so I didn't even have to think about positive or negative. Here clearly bx and by point in the negative directions, but that didn't come out when I computed this. So I need to add this negative number, this negative sign on each of these by hand, and I cannot forget to do that. I can see visually that they point in the negative direction, so I just add that negative sign by hand. Okay. There's one more point here I want to make. Imagine we had, let's think about A again, and that's 10 meters at an angle of 30 degrees here. We could, depending on the problem, we could cheat. So we could, it's okay if you're not told which way the x and y axis points, you can establish a slanted coordinate system so that in this case, ax would point totally in the y direction, totally in the x direction, and so the magnitude of the component ax would be 10 meters, and the component ay would be 0 because the vector A is perpendicular to the y direction. So oftentimes you want to do this, and it just depends on the particular problem whether you can do this. Sometimes you're told to use a standard xy coordinate system, and so that you just follow this procedure. Okay? All right, see you later.